See the structure of it. CH, CH, N, N, oh, CH2, 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 COO minus, again CH2, COO minus, CH2, COO minus, again CH2, COO minus. See how many donors are there? Nitrogen can donate lone pair. Oxygens, 4 oxygens can donate 4. So total is 6. So can I call this as hexadentate ligand? It is also can be flexidentate ligand. It can also be flexidentate ligand. Means its a coordination number may be either 4 or 6. It can donate 4 lone pairs or all the 6. So it can form flexidentate ligand. So it has flexibility to donate either 4 or 6. Acetate anion. O. Right? Next ID. Next ID. Here one small point I need to write, sir, regarding EDTA. If we are having any heavy metal poison, then they will give EDTA. They make us to consume EDTA or they will inject EDTA. This EDTA will form complex with heavy metals and it will be excreted out. Right? So there is one old JE question also. Once open your target booklets, 1 minute. They have not given map. No issue. Listen. For lead, mercury poisoning also, right? And also used for identification of to removal of hardness of water. And by adding EDTA, calcium and magnesium ions form complex with EDTA and it will precipitate, right? So EDTA complexes. So this with calcium, EDTA is forming a complex, right? This is central metal atom, calcium. This oxygen donate lone pair of electrons, this nitrogen, and this oxygen. This forms one square. Correct, sir? Is it forming one square? Octahedral complex, man. Right? Now, this oxygen is forming above the plane, below the plane. Is it octahedral complex or not? Right? So you are getting a ring here. Now this is old JEE question. Number of rings formed or number of chelations formed when EDTA forms a complex with any metal ion. How many ring structures are possible? How many rings are there? How many rings are there? Observe this. Do this forms one ring? One. No. Do this forms another ring? Correct? Then what about this one? Ring 3. Response, sir. Then what about this one? Correct? What about this one? How many rings possible? 5 rings possible. Check, sir. Is there any other possibility? Check. This is with the nitrogen oxygen, it is forming one ring or not? Check. This is one ring over. In the same way, with the below, is it forming one ring? Correct? Or see, it is in continuation with the nitrogen. Here, this CH3 is forming bond with nitrogen, man. Correct? So this forms one ring. Correct? Next, this oxygen, this carbon, nitrogen, and this one. This is another ring. Then this forms another ring. This with this up to this nitrogen. This forms one more ring. Correct? So 1, 2, 3, 4. This is another ring. Correct? Now say this. Number of rings. What they are saying? In an EDTA complex with a metal ion, 5 chelate rings are formed. EDTA acts as hexadentate ligand, meaning it means something they have to. Clear? So I am writing the same here. So it is an example of octahedral complex. Correct? Octahedral complex. Number of rings, 5 chelate rings. Response, sir. Coordination number 6. Right? EDTA is used for heavy metal poisoning. Response, sir. Means user means not to create, to treat heavy metal poison. Just a moment. Let me show that also. To remove or to treat heavy metal poisoning. EDTA is sometimes prescribed by doctors to clean toxic metals such as lead from blood. Doctors have used the molecule for decades to treat heavy metal poisoning. In those cases, it is given through IV. EDTA is also an ingredient in some prescription cancer fighting medicines, right? For treating heavy metal poison. Done? Right. So we are done with flexidentate, polydentate, both. Right? See the next heading. Any other pending in it? Done now? Let's say something, man. Right? One more example, sir. One more example. Nickel, sir. Ni+2 form cherry red complex. Cherry red complex with glyoxine. Dimethyl with DMG. DMG means CH3, C, again C, CH3, double bond N, O minus, OH. Dimethyl glyoxameto. This is that complex, sir. Right? Cherry red complex. So glyoxameto. So it is a bidentate ligand. And one old JE question, sir. Number of chelating rings possible in NiDMG twice complex. This is the complex. Number of chelate rings. Chelation means ring formation. Number of chelate rings possible in NiDMG complex. Can I take this image? Okay, I am taking this image. Yes, sir. Nickel acetate with 2 moles of DMG, 30 minutes in a retort forms this complex. I will write that in this way. This is central atom nickel. Carbon, single bond carbon, double bond nitrogen, double bond nitrogen. Yes, sir. Oxygen, O minus. Just a moment. OH, CH3, CH3. Here also same. N. Here also N. Double bond, carbon, carbon, CH3, CH3, OH, O minus. Here this nitrogen acts as a donor. Here also donor, donor, donor. There is hydrogen bonding possible here. Hydrogen bonding possible here. Now, sir, how many rings possible? Five. From where, man? Five. This forms one ring. 1, 2, 3, 4. Where is the other? Right? 4 only, na? The two rings are because of hydrogen bonding. If this hydrogen bonding is not there, then number of rings are 2 only. Correct? See this. Total number of chelate rings in NiDMG twice are. Right? How many? 2. If hydrogen bonding is not there, because of hydrogen bonding, you will get 4. Clear? Response, sir. Here also. If the number of chelate rings in a brown ring complex is A, and then FeEDTA is B, and the 5-membered rings in NiDMG twice is C, then what will be the value of B plus C minus D? Similar question or not? What is this brown ring complex? Array NO plus iron plus 1 state. What, man? FeH2O 5 times NO plus complex. Correct or not? This one. Another question. Number of chelate rings in FeEDTA, COEN twice, NH3CN, NiDMG twice, neglect chelation due to hydrogen bonding. They mentioned it. Then how many? What is the value of C now? 2. Are you able to understand? If they don't mention it, we'll count it as 4. So chelate rings equal to 4, including hydrogen bond. Right, sir? So we are done with this. Now polydentate density is over. What is the next idea? Classification of ligands based upon the type of bond it is forming with central metal ion. Just a moment. on the basis of type of donation of lone pairs, classification on the basis of type of donation of lone pair. On the basis of type of donation of lone pair. In which first one? Sigma donor ligands. Response, sir? What are sigma donor ligands? By donating lone pair of electrons, they should form only sigma bonds. Example. Most of the ligands are sigma donor ligands only. So by donating lone pair electrons to form coordinate covalent bond or sigma bond. Example. Water. Oxygen will donate lone pair to form sigma bond. Ammonia. Nitrogen will donate lone pair to form sigma bond. Carbon monoxide, is it sigma donor or not? Here I will mention this. Why I am mentioning this, sir? Why I am mentioning this? Lone pairs are available on carbon and oxygen also, but carbon acts as a donor, right? Next. Hydrogen. NH2, NH2. Response, sir. CH3, COO minus, etc. Now, one more important example. Cu NH3 4 times or Cu H2O 4 times plus 2 complex. We discussed copper is stable. Copper plus 2 is stable in aqueous solution. That's why I have taken this complex. Cu H2O 4 times plus 2. Now, how did it exist? Is it square planar or tetrahedral? Is it square planar or tetrahedral? Right? Square planar? Huh? 1 minute, sir. See this. See this statement, sir. Listen, listen. H2O act as strong field ligand in few complexes. Listen. Water is generally considered as a weak field ligand, not a strong field ligand, right? Whereas cobalt complexes, man, they simply made one statement. Exceptions. There are exceptions to this rule. When the metal ion is in higher oxidation state or is a part of 4D or 5D transition series, water can act as relatively stronger ligand. This is because of the increased positive charge and so on, right? So I will write examples of complexes with H2 acting as a, oh, something wrong, strong Ng, strong field ligand. Complex also, na? Yes, sir. See this? CO H2O 6 times plus 3. Nickel Ni H2O 6 times 3 minus. In some cases, cobalt plus 3 can also form complexes with water. What is it? Cobalt plus 3. Copper plus 3. Cobalt plus 3 already over. Copper generally forms plus 2, na? Copper plus 3 can also form complexes with water where it behaves as a strong field ligand. So these are the examples where water acts as a ligand, strong field ligand. Observe why I am writing copper in particular. Why I am writing copper in particular? See this. Copper electronic configuration, sir. Array, atomic number 29, man. Outermost configuration. 4s2, 4s1, 3d10 plus 2 state. In plus 2 state. 4s0, 3d9 plus 2 state. D9 means I am writing like this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Hey, it's okay. Hey, they are working, man. Go. Both are functioning. It's okay. Let them enjoy. Now listen. Right? Correct? Now 4s orbital is empty. 4s is empty, no? So 4s is empty. 4p empty. 3d have 9 electrons. Right? 4s is empty. 4p also empty. Now, if this electron jumps from here to here, if this electron jumps from here to here, then this d orbital is empty or not? Response, sir. And here you will have electron. Correct? Now, this d orbital, this s orbital, and these two p orbitals mix up. Hybridization is dsp2. Geometry. You have planar. Right? Now, one unpaired electron is present in outermost orbit or not? Is it possible to remove that electron? If I remove this electron, then is it possible to form plus 3? Are you able to understand why they gave copper plus 3 complexes where water acts as a strong field ligand? Understood or not? So I am writing that. Not only water, sir, ammonia, water, and so on. Here I am writing copper plus 2 only. I am writing copper plus 2 only, but it can show plus 3 state. Because of this electron, by giving sufficient energy, we can remove that electron and make copper to exist in plus 3 state. Square planar complexes. Hybridization. dsp2 hybridization. Understood? Next, sir. Pi bond donors. Ligands where pi bond electrons are donated. These are sigma electron donors. These are pi bond donors. So those ligands donate pi electron cloud. Array, stop talking, man, both of you. Example, sir. Cheese salt. Cheese salt. Here platinum, Cl minus, Cl minus, Cl minus, ethene, CH2 double bond CH2. Here this will donate pi electron cloud towards platinum. In remaining all the three are sigma donors. Right? Remaining all three chlorines are sigma donors, whereas ethene is pi electron donor. Any questions, sir? I am taking one more example. Ferrocene, chromocene, etc. ferrocene. To understand ferrocene, first see this one. Cyclopentadienyl anion. Right? Is it aromatic or not? Cyclopentadienyl anion. Right? It is aromatic compound. Aromatic means, can I say, its a resonance hybrid structure will be like this. I understand why I'm writing like this. The negative charge gets delocalized over all the carbons. Means every carbon is having negative charge. If every carbon is having negative charge, every carbon can act as a donor. Two pi electrons only involved in delocalization, right? So, how many pi electron cloud it is trying to donate now? 6 pi electrons it is donating. One negative charge, man. 2 pi bonds. 4. Totally 6 pi electrons it is trying to donate. Donated by how many carbons? 5. Every carbon is trying to donate lone pair of electrons, correct? Response, sir. So I am writing that like this. Are you able to understand? I wrote it horizontally. Now I am taking 2 molecules of it. I am taking 2 molecules. Between these 2 molecules, iron plus 2 got sandwiched. This is called ferrocene. Right? With each ring, every carbon, it is having interactions. Are you able to understand, sir? With every carbon, it is having interactions. Here, is it example of pi donor ligand? Cyclopentadienyl anion. Example of pi donor ligand. Say something, right? It is also written as eta 5 cyclopentadiene. Ferrocene. IUPAC. Observe it. Ferrocene. IUPAC name. Bis means 2. Eta 5. Why I am writing eta 5? Pi electron donors. 5 carbons are the donors. How many such species are there? 2 species are there. That's why bis eta 5 cyclopentadienyl iron. Is it clear? Eta 5 cyclopentadienyl bis iron 2. Why am I writing 2? Oxidation number of central atom is written in brackets. Oxidation number of means the next topic is IUPAC nomenclature. That's why I'm giving that bridge gap, right? IUPAC nomenclature we have to see next. So oxidation number of central atom or ion is written in brackets in Roman letters, right? This eta is called as hepticity. Hepticity. Denticity is different. What is denticity? Lone pair electron donor. Denticity. This is called pi electron. Generally in coordination number, what we discussed, we will not count pi electron donation. Right? We call it as hepticity. Hepticity in complexes. Something, refers to number of continuous atoms in a ligand that are directly bonded to the central atom. It represents by Greek letter eta followed by subscript. Okay, superscript number indicating how many atoms are involved in the bonding. For example, hepticity 3 means 3 pi electrons involved in bond formation. Clear? Yes. Continue, right? Delocalization, man, means there should not be any gap, no? Correct or not? All atoms are continuously involved in delocalization. For example, if I take CH2 double bond, CH2 single bond, CH2 minus. Now, do it involve in delocalization or not? Yes? Yes. So this will be shifted. This will be shifted. Resonance is possible. So can I write as CH2 bond CH2 bond CH2? Will you understand? That negative charge is between all the three. Right? So it is called eta 3. If I write the same CH2 double bond CH2, single bond CH2, again single bond CH2 minus. Now it is not continuous because middle CH2, this CH2 doesn't involve in delocalization. So continuity is missing. So I should not write eta 4. Is it clear? Understood now the meaning of continuous? Right? Any questions, sir? Now in this case, in G's salt, what I will write this as? Eta 2. Correct? So see the IUPAC nomenclature of G's salt. Array. Some letters, my keyboard was not working. No? Say this, what is the name of it? Potassium trichlorido eta 2 ethene. Response, sir. Eta 2 ethene platinate 2. Clear? So I am writing the same. Actually, I have to write this as overall charge is negative. So I have to write K, Pt, Cl3, CH2 double bond CH2, or I will write as C2H4. Response, sir. Eta 2 C2H4. Correct? So name, nomenclature. Potassium trichlorido eta 2 ethene platinate you can write platinate. What is the oxidation state of platinum? Overall charge is -1. Means platinum is to be in +2 state. So platinate 2. Response, sir. Any questions in it? Any questions about hepticity? Do you have any questions about hepticity? Next side heading, sir. Sigma donor pi acceptor complexes. Sigma donor pi acceptor ligands. Now tell me, what do you mean by sigma donor pi acceptor ligand? What is the meaning of it? Donate lone pair electrons to form sigma bond and accepts lone pair electrons into either pi or pi star orbitals. Response, sir. Right? Example, carbon monoxide. Correct? No. When carbon is donating lone pair of electron, what happens to bond energy of carbon and oxygen? When carbon is donating electrons, do lone pair of electrons of oxygen will be donating towards carbon more effectively or less effectively? More effective. Means it becomes more stronger triple bond. Means what happens to carbon oxygen bond order? Increase. Means bond strength, bond length decreases. Right? So I'm writing the same. I'm taking one metal. To that metal, carbon, oxygen, carbon monoxide. Carbon is donating lone pair of electrons towards metal to form sigma bond. Old JEE questions are again. For example, I am taking NiCO4, nickel tetracarbonyl. NiCO4 times nickel tetracarbonyl. CO is a strong field ligand. That field strength, everything we will discuss later. Carbon monoxide is a strong field ligand. Right? Now, what is nickel? Nickel configuration, sir? 4s2, 3d8. What is the oxygen state of nickel here? 0. A carbon monoxide neutral ligand. Right? Nickel is in 0 state. And strong field ligand, na? So these two electrons also come here and get paired up. Then what happens to configuration? 3d10, 4s0, 4p0. So what will be the hybridization? sp3 hybridized. So this is sp3 hybridized geometry, tetrahedral geometry. Right? Response, sir. Now, do nickel have lone pair of electrons in d orbital? Alright, D10 na configuration. So it have lone pair of electrons in d orbital. Now, in carbon monoxide, carbon is having empty pi star orbitals. Then this metal can donate lone pair electrons back to empty pi star orbitals of carbon, forming pi bond. Response, sir. Possible or not? So, metal, central metal, donating lone pair electrons to pi star orbitals of CO. Response, sir. We call this bond as synergetic bond. We call this bond as synergetic bond. If a synergetic bond is strong, or because of synergetic bond, bond order of CO, what happens? Bond order of C and O decreases. Bond energy of CO decreases. Bond length of CO. Any questions, sir? Then what about bond energy of metal carbon bond? Response, sir? No, I am writing one more point. This is the table given in Shriver-Atkins. See this table? This is nu bar, means wave number. Wave number of CO bond. Wave number of carbon oxygen bond. If wave number is high means bond energy is, wave number means bond oscillation, man. Right? So wave number is high means CO bond is stronger bond. Correct or not? Now, this is only CO molecule 2143. Manganese is in +1 state, chromium in neutral, vanadium in -1 state, titanium in -2 state. If a titanium is in -2 state means, do titanium have excess electrons? The titanium in -2 state, man, means it has excess electrons. If it have excess electrons, what happens to synergetic bond? Then what happens to CO bond order? Check. Correct or not? Respond. Any questions? Right? So, nu bar of CO is low due to synergetic bond. Old JE advanced question, sir. Any questions in it? Sigma donor, pi acceptor ligands. Say something. Now, is there anything left? Sigma donor complexes is over. Pi donor complexes is over. Sigma donor, pi acceptors over. Over, na? Pi donor, pi acceptors. G is salt. Right? Next slide heading, sir. List of ligands. I think no need to discuss. Anions means O. Cations means EM. Neutral molecules means, as usual, we will take the name. Right? No need to discuss that. Respond. So after the table, what is the next heading? So we are going to IUPAC nomenclature of coordination compounds. IUPAC nomenclature. Hey, Just now class started. Till now you are in break only, na? Class started at 2 o'clock only, na? Huh? 1 o'clock. 1 o'clock I gave break. You came back by 1:40, 1:50 maybe. Huh? Now time is 2:38. Not even 1 hour. If you want, go and come back. Go. Are you want break? Break means gone only. Lecture is gone. So okay, you are saying that get out of the class. Okay, I am going, man. Right, sir. Bye. You join for physics class. I am closing the session. Right, sir.